Hello students, in this lecture we'll discuss how to find out a resultant of concurrent force system. Where in previous two lectures we discussed about coplanar force system, its types, and then how to resolve a given force along x and y axis or resolution of force we discussed. This one is our next lecture where how to find out a resultant of concurrent force system we'll see here. Now, concurrent force system means lines of actions of all forces passes through single point. That means what figure are drawn here where number of forces are 3, F1, F2 and F3 inclined at an angle of theta 1, theta 2 and theta 3 with horizontal. So, line of action of these three forces passes through this point, right? So we'll give some name to this point as what? Say this point is a point O, called as point of concurrence. Now, if you want to find out a resultant of this force system, first we'll resolve all forces along x and y axis. That means here F1 force if we'll resolve, so it is a pull in nature, and components if we'll try, the horizontal component must be again a pull type, means pull in nature, right? Horizontal component must be pull in nature. Therefore, horizontal component must be rightward. Okay. And what about vertical component? Vertical component again of same type, means pull in nature. Therefore, here vertical component will get in upward direction. Now you know how to find out magnitude of this component. The magnitude of horizontal component for this force becomes what? F1. Now inclination of force is given with horizontal theta 1. That means horizontal component what will get here? Cos of theta 1. Vertical component if we'll check, it is F1. Now vertical component will be definitely sine of this angle theta 1 because the inclination is given with horizontal. Second force will resolve F2. Again it is of pull type in second quadrant. That means horizontal component will get in leftward direction, and vertical component if we'll see, vertical component is in upward direction. Now magnitudes of components are important. Magnitude of horizontal component F2, again inclination is given with horizontal, therefore this component is what? F2 cos of theta 2, and vertical component is F2 sine of theta 2. Similarly, next F3 force if we'll resolve, so for F3 force, direction of horizontal component will be where? Rightward, and vertical component will get where? In downward direction, because F3 is also a pull type of force. Therefore, components also of pull type, and in this case also inclination what is given is with horizontal. Therefore, horizontal component becomes F3 cos of theta 3, and vertical component is F3 sine of theta 3. Now, when we will find out resultant means what? Basically, all the given forces acting on a body, or what will be the number of forces given in force system, all forces will replace by single equivalent force. The single equivalent force is called as what? Resultant. For concurrent force system, what we'll do, as inclined forces are given, we resolve all the forces, we'll add all forces in horizontal direction with proper sign convention. Now here what sign convention we'll use? Along a positive x-axis means a rightward force means positive, and if it is in upward direction then it is positive. That means this is a positive y direction, this is our positive x direction. Any force acts in horizontal direction, rightward means positive, that means in reverse leftward means negative. In vertical direction, any force acts in upward direction, we'll substitute with positive sign. If it is in downward direction, we'll substitute with negative sign. Now if we'll add all forces along x-axis, what we'll get here will represent by Rx, meaning is what? Component of resultant along x-axis. How we'll add? It is summation, right? Forces along x-axis. That means this is our general equation, and we'll put here sign convention also. Rightward force is positive. That means here what will get here, Rx adding these forces. That means if we'll write these terms here, that is F1 cos of theta 1, next F2 cos of theta 2. Now F2 cos of theta 2 is positive or negative is very important. F2 cos theta 2 is acting in which direction? Leftward. Leftward means here while writing this term becomes what? Negative. Component of F3, again horizontal component, F3 cos of theta 3. When magnitudes and inclinations are given, we can find out this Rx equal to some Newton or unit given if say kilonewton, so this one is a kilonewton. Again what we have to decide, what is important, Rx what will get, that may be positive or negative. If Rx comes out to be positive, we'll represent it in rightward direction, and if it comes out to be negative, we'll represent in leftward direction. Then we'll add all forces along y-axis, and what we'll find out is called as component of resultant along y-axis. That means Ry is what? Summation of Fy. Therefore, in summation of Fy now, if we'll add forces to first component, that is F1 sin theta 1 upward positive, then F2 sine of theta 2 upward means what? Positive. But component of F3 is in downward direction, that means this one comes out to be negative, F3 sine of theta 3. Therefore, what will get here, again Ry, substituting values of forces, inclination, will find out this Ry. Now, to represent here resultant, what will assume here, along x-axis what Rx you are getting is say in rightward direction, means positive answer you are getting, and what Ry you are getting, that one is say vertically upward. That means what, as per direction what will get, will represent here as maybe rightward, leftward, upward or downward. So in this case, assuming Rx, Ry are positive values, what will get here? Rx, and this one is nothing but what? Ry. Now as two components of resultant you are getting, that will pass through same point of intersection O. The resultant of these two will represent here, which one is in which quadrant. How will decide? You know any force is of pull type, components also of pull type. Now here components are of pull type, therefore this resultant force will get of pull type. Therefore this force what will represent here is what? Your resultant R. Right. Now next step important is what? How to find out magnitude, means what? R, and its inclination, say angle theta with horizontal. To find out this R, we'll use our Pythagoras theorem to find out resultant. If we use Pythagoras theorem, so that R is given by what? Square root of this Rx square plus Ry square. Using this Pythagoras theorem, we'll get magnitude of resultant force. And inclination, if you want to find out, we'll use simple tan of theta. Now tan theta means what? Opposite upon adjacent. What Ry I represented here, that is nothing but same length, you can say here, opposite to this angle. That means Ry is opposite side of this angle, Rx is adjacent side. Therefore tan is what? Opposite upon adjacent. That means Ry upon Rx. That means theta, when you will find out, will take tan inverse of Ry upon Rx. That means to find out magnitude of resultant, first step is what? Will resolve all forces along horizontal and vertical direction. Add all forces along x-axis, will get component of resultant along x-axis, that is Rx. Simply add all forces along y-axis, and if we'll add, we'll get what? Ry, means component of resultant along y-axis. Depending on sign of Rx and Ry, represent graphically. So Rx may be rightward, leftward, Ry may be upward or downward, depending on plus minus sign. Assuming they are positive, I represented here in figure, Rx rightward, Ry upward. And then resultant will get of same nature in between these two forces. What R you are getting, its magnitude will find out using Pythagoras theorem. So R is square root of Rx square plus Ry square, and tan of this angle theta is what? Ry upon Rx, means theta equal to tan inverse of Ry upon Rx. The resultant of concurrent force system always passes through point of concurrence. Point of concurrence means what? The point through which all forces passes. That means here point O is what? Point of concurrence. So this resultant of this concurrent force system, this one passes through. This one passes through which point? Passes through point of concurrence. It passes through point of concurrence. Thank you.